Welcome again to Let's Talk Chemistry, Advanced Chemistry, Chemistry 2 with Pastor Dan. I know in the last video I said we're going to do gas laws next. Unfortunately, when I look back at the video, there's a concept in this over here, this concept solutions, that I need to make sure that I looked at so that we can move forward. So we're going to start back there, then we'll go to gas laws next. So solutions. Solutions are defined, as we talked before, they're homogeneous, mixture, homogeneous, uniform all the way throughout, mixture, two or more things combined physically. Now, when we look at a solution, again, there are two parts. We have, first of all, the solute. The solute is defined as a substance that is dissolved, what is broken apart. And the second part is called the solvent. The solvent is defined as substance doing the dissolving. All right. Now, we do need to make sure we understand some basics. We talked about this in Chem 1. I'm going to talk about it again just to make sure that we're good. Solubility, there's three different ways we can have soluble. You can have less than the solute, so you can unsaturate it. Could put more in there. We could put saturated. All of the solute can take, Captain, she can't take no more. Good Scotty impression, not quite so good. Having all that it can. And then supersaturated, having more, using pressure and temperature techniques, we can make a solution supersaturated, having more than it really should be able to hold. All right, now, when we do solutions, we do need to understand something called dissociation. We're going to talk about that. We'll get normality. Dissociation is the process of breaking an ion into its base, ionic compound into its base compound, ions rather. So in HCl, we have hydrogen ion and chlorine ion, and if it's strong, it goes one direction. It's not in equilibrium. Try these two, pause it on your video on your own, see if you come up with it. So if we have iron 3 hydroxide, then we have ammonium phosphate. Go through and dissociate those, see what you get. Hopefully you should have gotten Fe3 plus 3OH minus, because there's that 3 in the subscript. We have to put 3 out front, and then get 3NH4 plus PO4 3 minus. Again, that 3 subscript becomes a 3 out front for ammonia. A couple more quick definitions. We have some miscible when two liquids dissolve into each other. Aqueous if the water is a solvent. Tincture if the alcohol is a solvent. And alloy and metal solutions. If you need to copy these down, pause the video, write them down. That's all good. Awesome. Alrighty. Now, units. We talked about 2 units before. We're going to add some more to it here. So the 2 we've looked at so far are molarity and molality. Molarity is moles of solute over liters of solution. Molality, moles of solute over kilograms of solvent. The unit for molarity is capital M, molality small m. All right. Now I'm going to do 2 of these, one of each way. So let's talk. The first one, determine molarity of 41.878 grams of barium fluorate dissolved in 535.35 milliliters of solution. So we're finding molarity, capital N, which of course is moles of solute, liters of solution. My solute is the 41.878 grams of barium phosphate, fluorate rather. Barium is 137, fluorine 19 times 2, 38, 30, and oxygen 16 times 6 is 96. 96, 38, and 137 is 271 grams of barium fluoride in 1 mole. We're going to take that value, and then we're going to find number of liters. So a liter is 1,000 milliliters. That value goes in the bottom. We divide them through. We get 0.28865 molar BaOFO3 parentheses twice, and that's my answer. Now, we've done these before, so give this one a shot on your own. Find the mass of sodium hydroxide needed to make 1.580 molal. Okay, if you have 350.0 grams of solvent, and what solvent usually is, hopefully you remember, solvent is usually water. So pause the video, give it a shot, see what you come up with. All right, here we go. So we're going to take that 350.0. We never, ever start the concentration. We start the other value. 1 kilogram is 1,000 grams. molality 1.5. Use that molality as a unit converter, so kilograms goes to moles. 16, 1, 30, 23, 40 grams is 1 mole. Multiply through, we get 22.12 grams of NaOH. All right, those are reviewed. Now, there are other solutions that we looked at. The other unit solution we want to look at are called assay, ppm, ppb, mole fraction, and normality. Now, the first three are pretty straightforward and easy. For assay, we have the amount of solute over amount of solution times 100. Now, that can either be mass of solute, or mass of solution times 100, volume, milliliters, or liters, or mass volume. If it's going to be, if it's not specified, usually it's mass. For ppm, the expression there is percent. All right, for ppm, it's the amount of solute over amount of solution times 1,000,000, 1 times 10 to the 6. And we express that as ppm. ppb is times 1,000,000,000, and again, ppb is the units for it. Now, mole fraction. Mole fraction is just X. X is the moles of solute over total number of moles, and normality is a value A times the molarity. Now, how do we find A? Well, if we had some like sulfuric acid, we dissociate it, like I showed you before, dissociate it into 2H plus SO4 2 minus. That multiple in there is the 2, and so that's where we get the A value would be. All right, so let's take a look at the assay problems first, because they're pretty simple. We're going to do those quick here first. So calculate the assay of a solution that contains 23.89 grams of copper 2 sulfate in 311.5 grams of solution. So we just can put our values into each other. Divide them through, multiply by 100. Straightforward. Answer 7.669% CuSO4. That's pretty straightforward. That's pretty easy. Shouldn't be too much of a problem. All right, now we can also do these the other way as well. So I can ask like this: what mass of calcium chloride is needed to make 13.95% solution if there is 29.22 grams of solution present? All right, now, do we ever start with a concentration? Remember, no. So we're going to start with that 29.22 grams, put that over 1. And we're going to do the same thing we did before. We're going to use that 13.95% as a unit converter. That's calcium chloride, CaCl2. Well, how much would that be? Well, what number would I divide 13.95 to get, remember, a percent, moving it 2 places to the, over 2 places to the left. To get 0.1395, we're going to divide by 100. So multiply through, 29.22 times 13.95 equal, divide by 100 equal, and we get 4.076 grams of calcium chloride. That's my answer. All righty. Now, this next two are ones that are different. We haven't talked about before, so let's go through them a little slower. Calculate the mole fraction of 35.22 grams of sodium chloride in 100 grams of water. Now, we said before that that's X. And we said the mole fraction is moles of solute over total number of moles. So what's my solute? My solute here is NaCl. So we're going to have to find the moles of NaCl divided by total number of moles. So my NaCl is 35.22 grams of NaCl, and that's over 1. Sodium is 23. Chlorine 35.5, so we get 58.5 grams of NaCl. Take 35.22, divide by 58.5 in your calculator, and we're going to get 0.6021 moles of NaCl, and that goes on top. All right, now total number of moles. Well, the other substance in here is water. So we have 100.0 grams of water. Hydrogen's 1 times 2 is 2. Oxygen's 16. 16 plus 2 is 18 grams. Is 1 mole. So we're going to divide that through, and we're going to get 5.556 moles of water. Now, we want to find the total number of moles. How are we going to do that? We're going to add them up. So take 0.6021 plus 5.556, and we get 6.158. Remember, last field column, 3 decimals. All right, we're going to put that on the bottom. When we take 0.6021 mole, divide by 6.158 mole, my moles cross out, I get 0.09778. That's it, no units. That's how we find mole fraction. Pretty straightforward, pretty easy. All right, now last thing we'll look at is normality. Now I'm going to tell you, normality is a odd duck. The only time I've ever seen anybody work with it are usually older bioorganic professors. So if you end up do a bioorganic, you might be asked for normality. It's not too common beyond that. I think there's only one time in my entire professional career when I worked in a plastics lab that I had to do a normal situation. So normality, we said, was A times molarity. So we got to find the molarity first. So molarity, again, is moles of solute over liter solution. And my solute here is aluminum hydroxide, AlOH 3 times, which we said that's the grams, 18.955 grams over 1. We're going to take 78, 27, 16 times 3 is 48, 3, 48, and we end up, and multiply through. We get 0.24301. And then we're going to convert my liters, moving 3 places to the left, 0.15055 liters, multiplying through, we get 1.6141 molar. Now we said that we need to find this A value. How do we find that dissociation? So aluminum is going to give us 3 hydroxides. So the A value is 3. So we're going to plug that in there. 3 times 0.16141 molar, and we're going to get 4.8423 normal aluminum hydroxide. That's my answer. So those are our new concepts of solutions. We're going to do a few more solution things from here, but that's our first one. We'll practice tomorrow. Hopefully not too bad. Take care. God bless. Bye.